squared minus 21 sine theta plus 4 equals 0. Hopefully you guys can visualize that this thing is in the format of a times something squared minus b times something to the first plus 4 times, ultimately it's something to the 0 power. Okay, my something being my variable term like u or whatever. Call that c instead. But it's quadratic in form, right? Okay. Now, I don't know what's happening. Okay. So it's quadratic in form. So we should be able to factor this thing using any one of our factoring techniques. Okay. Now, when I say any one of our factoring techniques, it could be the product and sum technique that we learned in Algebra 1. Two numbers multiplied together give me C, that give me B. Could be A times C method. Could be quadratic formula. When these things get large enough, it could be something like maybe the rational root theorem. We have the ability right now to really factor pretty much anything we come across to a certain degree. And that is the kind of the set of tools that you would use to factor any one of these. Okay. Now in this one, I think the most obvious way of factoring it is the A times C method. Okay. Hopefully you see when you see 5 and 4. Hopefully when you see that 5, the first thing you try to do is say, okay, is everything divided by 5? And not everything is divisible by 5 here. So then the next thing you say is AC, A times C. And you see 5 and 4, and doesn't that relate real well as a product with negative 21? So we should be able to factor this thing pretty nicely. Now, whether you are a person that likes to do this or not, I'm going to show it just to give you options. But some people prefer to get the sign word out of the equation before they do anything. Okay, so we do something like that. Let u equal sine theta. Okay, basically making it that thing right there. What is your b term essentially, or the I guess the variable component to your b term. So then you can rewrite this thing as 5u squared minus 21u plus 4 is equal to 0. And that might be a lot easier than for you to recognize it's the A times C method. So I'm going to rewrite this as 5u squared minus 20 minus then that's 20u minus 1u plus 4 is equal to 0, right? We do the A times C method. We do 5 times 4 is equal to 20. Now two numbers that multiply together give me 20, but add up to give me negative 21. There are these two numbers that we put here. Remember doing that? Okay. We start grouping these things, and we find that in the red arrangement, there should be a 5u in there, right? So that gives me a u minus 4. And then over here, to get u minus 4, I just need to factor out a negative 1. So this will give me 5u minus 1 equals 0. U minus 4 is equal to 0. U then becomes 1/5, and u becomes 4. And now at that stage, all you've got to do is go back, because we just solved for u. We remember we're trying to solve for theta. So you go back one substitution and say, okay, now sine of theta is my u. So sine of theta equals 1/5. And here I'll say sine of theta is equal to 4. Is that all right? Hopefully those are all things that you remember from algebra. And the idea, guys, is we might not be extremely proficient because we're juniors and seniors at high school. We've only been maybe using these things for 2 years or 3 years or maybe 5 months or something like that. But we have essentially learned all the algebra right now that we need to be able to navigate through the rest of the mathematics. Okay. Now we maybe haven't learned enough math to explain and make a realization of all of that algebra and connect it. but we do have the ability in all the processes that we've learned to essentially see any type of algebra in that is structuring some other type of question to be able to navigate through that algebra. Does that make sense? Okay, so the factoring here is the structure for this trigonometric equation that we have the skills already developed for. Okay, now we've got to go a little bit further once we've solved for sine of theta, because remember, we're always trying to solve for our variable. Well, sine theta is not your variable. Theta is your variable, right? Okay, so we want to solve for theta. We basically want to say, okay, what angle measurement do I have to plug in right here and right here to get 0? Okay, well, right now I don't have that. Right now I've got the sine of theta. I've got the ultimately the ratio that I plug in. I want the angle. Okay, the sine theta equals 4 is probably the easier one to deal with. Think about what this is. Remember, every time we work with equations, no matter what stage in the equation we are at, it is an equation, and that means that the left-hand side is a graphical representation, and the right-hand side has a graphical representation. So sine of theta should look, something like that. I'm just going to put it in one cycle, one revolution around the unit circle. So that would be this left-hand side. And 4 would maybe be that dotted line right there. And if those two things are equal, the solution for theta is the x value where they cross, right? Where do they cross? They don't. Okay? So sine of theta equals 4. That provides no solutions. Okay? No solutions from that. Okay? However, sine of theta equals 1/5. Well, 1/5, if that's 1 right there, 1/5 might be like that line there, right? How many times does that red line cross the blue curve? Twice, right? So we should be able to find 2 solutions out of this. Okay? And the way we do that, obviously, to find theta, we're going to take the sine inverse of this side. Sine inverse and sine undo each other, right? And that gives me theta. Tablet's being kind of weird today. Yeah, it just had a fit. All right, so theta. And then the right-hand side is going to be sine inverse of 1/5, right? So that's where we've got to grab our calculator, because we don't know 1/5 off the unit circle, okay? If it was like sine inverse of radical 3/2, we know that from the unit circle right away. Okay, it'd be 60 degrees or pi/3, right? But 1/5 is not one of those convenient values off the unit circle, so we grab our calculator, and we're going to make sure you're in the mode that you feel comfortable with, okay? And what I mean by that is, when I do it, I just pay attention to what the question is asking. Does question 1 in degrees? Because that's in the mode that I want to be in. If it's in radians, then that's the mode I want to be in. If you're a person that says, I am always a degree person, that's fine. But know that sometimes your answers need to be in radians, right? So if you do everything in degrees, make sure at the end you use your conversion from degrees to radians to get into the format that the solution needs to be in. We'll kind of talk about that here in a moment. I'm going to do everything right now in radians, okay? Because I think that's the one that we need the most practice at. So if I go sine inverse of 1/5, okay, it gives me that number right there, okay? So that number, guys, if I were to look at this graph over here, that number is the x value, or if we let this be our theta axis or whatever, it's the independent variable for where these two things cross. So that's 0.201. I'll just go 4. Okay. Now we have to do a little bit of work to find that other one. Okay. And finding that other one is the reason that I don't think it's beneficial that when we're trying to find these solutions to actually look at this type of curve to do that. Okay. I think that to find your other solution, it makes more sense to look at the unit circle to find that additional intersection point. Okay, it says sine inverse of 1/5, meaning that your ratio of opposite to hypotenuse on the unit circle would be 1/5, right? And it's positive, so that should exist in the first quadrant, meaning that's a 1, that's a 5, and that there then would be the theta that we're looking for. Does that make sense? The sine inverse just gave that angle to be 0.2014. Okay, so that's kind of the representation of that point kind of in a unit circle format. Does that make sense? All right. To find this other point, okay, it means that the y value, the sine value again, is positive. What other quadrant does the sine value exist as a positive number? Second quadrant. So that would still be 1, and that would be 5. And now the angle that we're looking for, guys, would be that blue angle. I'll just call that theta sub 2 right now. Okay, but how big would that shaded angle be? Yeah, it's that one right there, right? It's a simple reflection across the y-axis, okay? So how do I find theta sub 2 then? Right, if my blue angle would go all the way down to the x-axis, that would be pi, right? Or if we're doing it in degrees, it'd be 180. But I'm coming up a little bit short of that. Okay, we're coming up a little bit short of that. So when I come up short of something and I want to figure out what that amount is, I'm going to take where I would normally go. I would go that full, complete movement and then remove the amount that I'm short, right? Okay, so I'm going to take pi. And remove from it that amount there, and it gives me 2.94. Okay, so this other theta is 2.940, and that's radians. Both of them in radians. And those are my two solutions then that are provided in this sine of theta equals 1/5 factor for that original equation. Can we check ourselves? Okay, we should be able to do this. There's a couple different ways you can do it on your calculator. Maybe use the one that's, I think, most efficient for us. I just typed in the equation into y1, okay? And you've got a couple different things you could do here, but the easiest, I think, is to kind of bypass the graph, okay? If we were to look at the graph, it's this thing here, and I'm zoomed out, so it's really not showing the whole thing. It's going to be kind of a struggle maybe to determine which solutions we're interested in here. Basically, that one right there where my cursor is going to be 0.2014, and this one here is going to be the 2.941. And we can find that just by going to like second calc, go down to 2, which is the 0, hit a left bound, move my cursor to the right of where I think that 0 is, hit enter, hit guess, and you see that does give me that number, right? Okay, and then we would do it for that one, and then however many you have, maybe you can do it for that one, you can do it for that one, and so forth. Does that make sense? Okay, but I think the easiest thing is actually go to second table, and if your table like auto fills like all the way down and you can scroll all the way down, then you want to go to second table set and make sure that this is highlighted as ask. Okay, and your independent variable, that's your theta in this case. And we'll go back to second table, and now it's blank, and that means I can just start typing things in here. And what we're going to do is type in our solutions. We're going to type in the 0.2014 number. And we see that we get that, which that's pretty close to 0. That means negative 0.0008. Okay? That e negative 4 means times 10 to the negative 4. Okay? Now, it's obviously wrong, or I guess not seeing necessarily a 0 here because we rounded, right? But if I did this, if I went second sine of 1/5, put that in here, see how that gives me 0? And now you see the difference. Let me go back real quick. Now maybe you see the difference between that number that gets inputted as x and that number that got inputted as x. Does that make sense? And that's making up for then the difference between these outputs. But we also found, was it 2.94? 2.94. Now, here it's going to give me that. Okay, if you went out a couple more decimal places, it would probably bring in that times 10 or e expression. But that's pretty close to 0, isn't it? And the only reason it's not is for the fact that we've done some rounding. If I want to eliminate rounding, I could say, well, I took pi and I subtracted from it the sine inverse of 1/5 as an exact value. And there's that 2.94 number to more decimal places. And you see that result is then 0, right? Okay. So you can check yourself that way. You can check yourself on Desmos probably a lot quicker than any of those. You know, if I go 5 sine squared of x minus 21 sine of x plus 4. Click on just the curve, and it's going to give me my interception, give me all my x-intercepts, even gives me my y-intercept, 0.201. And I think there should be a way that we can get that thing to show more decimal places. But that was the 0.2014 that we came up with, and then we can click on this one here, and you see it's the 2.94. Okay. If you go to settings, maybe somewhere in here, I'm not sure where. I don't know, you might have to do a little bit of work to figure out how to show that in more decimal places, but I think that's enough to see that we've done things correctly. Does that work? How do I get these other ones? How do I get that one? Yeah, okay, I'm going to add 2 pi to that one, right? 2 pi is 6.28 as a decimal, right? Take that number, add 6.28 to it. Just give you that number. Yeah. Okay, so the infinite number of solutions would be theta equals 0.2014 plus 2 pi k and 2.940 plus 2 pi k. Now I use 2 pi because that's the what for the sine function. That's the period. Okay. Is that something we can do? All right. You could have also used, that's A, and that's B, and that's C. Could I have used this thing? Yeah. But when you use that thing, what are you usually solving for? Because you're using it for this usually, right? So you're solving for x. But right now, this is A sine squared theta plus B sine theta plus C. So now what would you be solving for? Sine theta. If you plug all those coefficients in as, you know, A, B, and C that are 5, negative 21, and 4 respectively, you will get that quadratic formula to dwindle to 1/5 and 4. So that's, you solve sine of theta for 1/5 and sine of theta for 4. Does that make sense? And then you can kind of pick up where we, what we just kind of explained with the calculator. What's this one going to affect? If I just let u equal cosine theta, This one's going to be u squared minus u minus 30, right? What's that factor to? U minus 6, u plus 5. So is that going to give you u equals 6 and u equals negative 5? When does cosine of theta equal 6? Never. When does cosine theta equal negative 5? Never. So your graph of this thing, I'm not going to spend time graphing it, would be, it kind of does something weird down here. Kind of looks something like that. Never crossing the x-axis. Does that make sense? So you could go through a lot of work and realize that there are no solutions, because just like any other equation, there are times where your curves or your lines do not cross each other, right? Okay. There's no time we get out of here. 34, fantastic, plenty of time. What's the GCF in example 7? Tangent. Okay, so take the tangent out, and that's going to be 5 sine of theta minus 4 equals 0, right? So tangent theta times 5 sine theta minus 4 equals 0. So it's a product of two numbers, and you get 0. So tangent of theta is going to equal 0. And the 5 sine of theta minus 4 is going to equal 0. This eventually gives me sine of theta equals 4/5, correct? Now this is just like example 6, like example 5, like example 4, where we look at those values of 0 and 4/5, and for the respective trig ratio, do we know them off the unit circle? This is a really nice number. You should know that off the unit circle. Okay? Because tangent is sine divided by cosine, right? These are the only spots that I could potentially get 0, because everywhere else I have sine and cosine values that are non-zero. Okay, so I'm going to get a quotient that is non-zero. Here I get 1 comma 0, right? Can I do that division for sine divided by cosine? Yes. Okay, so that means that 0 radians is a solution. Can I do that division, sine divided by cosine? No. Can I do that division? So where's my other solution? Pi radians, right? Does that make sense? So those are your two solutions right now for tangent theta equals 0. And then for the same reason, I can't do that one because I get division by 0. Okay. Sine of 4/5, what do I have to use? Got to grab your calculator, right? Okay. So I'm going to grab my calculator. I'm going to go sine inverse of 4/5. Hit enter. So it gives me theta to be 0.927. So it's giving that angle there of theta. How do I find this other angle of theta? Subtract that number from pi. So I'll go pi minus that last thing. It gives me theta to be 2.214. Okay, so very similar, right? But the only reason I show this one is because you do something a little bit different when we want to show the infinite solutions. What is the period for sine? 2 pi. So I'm going to write plus 2 pi k here, and I'll write plus 2 pi k there, right? What's the period for tangent? Pi. So I'm going to write plus pi k there, plus pi k there. And what happens is that 0 plus pi k is redundant of pi plus pi k. verify the same solutions over and over. But those four solutions are what we're looking for. I just went ahead and graphed this for us to show these solutions. So here we get, there's your 0, which would have been this 0 radians here. Okay, pi shows up right there. Okay, so there's 0 and pi. So the other two right here must be the ones from sine of 4/5, or sine theta equals 4/5. So that's 0.927. So let's see if we had that 0.927, and then the last one's 2.214. So 2.214. And then I don't know if I can do this correctly, but let's see if we can. Let's say that we take. Well, let me do something in GeoGebra real quick. All right, so I just moved over to GeoGebra, and we see then that you know, if I ask for these intersection points, it might even be better to just ask it for its roots. There we go. If I take, so E was at 0.67, which that 0.67 is, let's see here. Oh, I got the wrong thing typed in here. There should be a tangent. There we go. All right, so that D right there was a 0.93, which we go out to a couple decimal places. Is actually the 0.927 number we came up with. So if I take that, so that point D, take its x value and add to it 2 pi, keep the y value 0, so it's going to produce a point that's on the x-axis. That should show up then to be one of the values we already have, one of the points we already have. So let's color that, and we'll see if we can find that point over here. Oh, they didn't color the way I wanted to. I want that color to be red. There we go. So, I took point D, which came from the sine of 4/5, sine theta equals 4/5. And add 2 pi to that solution, and it gets me that point there. Okay, I should be able to take this one here. Okay, and that's 0. So the 0 solution came from tangent. So we took. Let's just take the x value of c and add pi to that x value, and keep the y value at 0. Get that point there. Let's make that one red again. So it gives me that one. So that point there went there. D went to there. We should be able to take E. Take E. That came from the sine function. Add 2 pi to that, and it should give me some solution over there. Okay. And then I should be able to take this F, which F is the 3.14. So F came from the pi solution. So I take the x value of F, add to it pi. Okay, let's make that red. So we see then that that's going to go to J, and I've moved things. There we go. And it gets me to J, which is also on the curve. So I guess what I'm saying, I don't know if I did a really good job of that. Just kind of on the fly here. But what I'm trying to kind of explain is that the two values that came from the sine, we had to add 2 pi k to those to get the repeat values in the other
kind of rotation around the unit circle, or if we look at this, the periodic nature of the curve, to get all these other endless solutions that are attached to uh, that one there and where is it? That one there. Those two, we have to add 2 pi to come up essentially with those two. Okay, um, to get that one and that one. Okay, because they came from the tangent. The tangent has a period of pi, so we only have to add pi k to those. Now the thought is that these two, I mentioned this at the end of class, these two are redundant. Depending on if k is 1 right here, I get the same as if k was 0 down here. So these two things give me the same results, just varying k values, and that doesn't matter. K can be any integer we want it to be. So all of these, this formula here, all of those can be found using this formula as well, or vice versa. So in the whole grand scheme of things, if you didn't write one of these, you're okay. You still have all the solutions.